Oh, okay, we've got question 2 from the June 2008 paper. And as soon as you see this diagram here with a sector of a circle, you need to think about your formulas from your learning sheet. So you've got formulas for arc length and for sector area and for areas of triangles and other stuff. Okay, so you need to know those formulae. I won't help you with that. But find the length of the arc PQ, length of the arc, so you quote your formula for arc length. You've got to give your answer as a multiple of pi, which is fine because the theta there is in terms of pi. So don't give it as a decimal. Find alpha in terms of pi. So here's alpha here. You don't need anything from your learning sheet here, but what you do need to do is recognise that if there are 14 centimetres, the same radius both sides, this is a certain kind of triangle, which should enable you to predict what that angle is the same as. And as soon as you know two angles like that and the other one you need to use the fact that the angle sum of a triangle, the sum of the angles, is in degrees 180, but we're in radians, so it's pi radians. That's GCSE knowledge. The sum of the angles of the triangle is pi, so you can find the missing one in terms of pi. Leave it as a fraction times pi. And then for the perimeter of the shaded section, okay, we're going to be using the arc length PQ. So the arc length PQ that you found in A was the curvedy bit, and we've got to add on the straight bit PQ for the perimeter. So we've got to find the straight bit. There are two ways to find PQ. One is to use the triangle OPQ. We know two sides and an angle, so you can use the cosine rule, which is in your formula book. Okay, you may have thought of another way to do it, which is by splitting it into two right angle triangles, and you can make that work as well, but I suggest the cosine rule. Okay, that's that question sorted. Get to it.